All right, here's a video for 4.5 practice A, and I'm just going to walk you through the work on them. And I didn't do all of them. You only have to do the ones you see on here. There is a Google Doc that you'll be putting a few graphs on, like 5 different graphs. So I did a couple here so you can see how to do them. And let's see. All right, so number 1. Now, we're going to be solving equations. So we learned in the last section how to factor. I just want to go back up here for a second and remind you of the factoring steps. Always going to look for GCF first. We'll look for a difference of perfect squares. We're going to use the x if there's no number in front of the x squared term. If there is a number in front, we could use the star. If there's 4 terms, we can use the box, or we can look for a sum or a difference of cubes. But to solve these, we are going to need to factor them to make them smaller, break them down. So let's start with number 1. Immediately, when I look at number 1, I see that every term has a q in it. Okay, so I'm going to divide everything by q right here, dividing everything by q. So that's going to make my GCF be a q. And then what's left over, if I had 3 q's and I take away one of them, I'm going to have 2 q's left. Have 2 q's, take one away, you got one left. It's like a negative 1 q because there's nothing in front there. And then you had negative 30 q, but you took out the q, so it's just negative 30. Now you got nothing in front of the x squared, so you can use the x to factor it. You can put the negative 30 on top, put the negative 1 on the bottom. What numbers multiply to give me negative 30 and add up to negative 1? You'd have to use a negative 6 and a positive 5. Those two would make negative 30 when you multiply and negative 1 when you add. So negative 6 is one factor, positive 5 is the other factor. What would make it 0 is a positive 6, so that's one solution. What would make this 0 is a negative 5, that's another solution. And whenever you got a letter on the outside as a GCF, that's a 0 answer. That could be a 0. Because if you put a 0 for all those, you're going to get 0. So now you can pause the video and catch up at any time since they're already written. I might move a little quick, but you can always pause the video when you need to. Number 2 I'm not going to do because it's almost the same as number 1. So let's look at 3. 3 we have to get it equal to 0. So the first thing I did was I added 3y squared to both sides so that it would equal 0. Then I looked and I saw, okay, wait a second, we got a GCF here. We got a 3 that we could divide everything by, and we got at least 2 y's in everything. So I took out a 3y squared. I divided everything by my GCF. The 3's canceled. You had 4 y's. You took out 2. You got 2 left. Negative 6 divided by 3 is negative 2. You had 3 y's. You took out 2. You got 1 left. Negative 3y or 3y squared divided by 3y squared. Those are just the same things exactly. You get a 1 when you divide the same thing on top and bottom. So once again, you can use the x. A 1 goes on top, and negative 2 goes at the bottom. Negative 1 times negative 1 is positive 1, and when you add them, you get negative 2. So you get a 0 for one solution because there's a y on the outside as a GCF. And you don't have to put y minus 1 twice because there's 2 of them. You can just put it once with a squared, and you're going to get the same answer both times. It's going to be a 1. So 0 and 1 are your 2 answers. So there's 3. Now, 4 has 4 terms, so we do want to look at that one. It has 4 terms, so let's put them in a box. Anytime you see 4 terms, put them in a box where there's 4 spots. So we've got your 4 terms in there, and then we're going to only look for GCFs. GCF straight down and straight down, GCF across, GCF across. So straight down, these both have an N in common. Straight down here, they both have a 2 in common. They don't have a sign, so it's just a positive 2. Going across the top, they have at least 2 ends. This one's got 3 ends, this one's got 2, so they both have at least 2. And going across here, they both have a common negative, and you can divide them both by 9. So n squared minus 9 is one parentheses, and n plus 2 is your other one. So this one you would just bring down with a negative 2. That's one solution. What would make it 0 is a negative 2. Negative 2 plus 2 would be 0. N squared minus 9, though, is a difference of perfect squares. You got a difference. You got 2 perfect squares, so make them n plus 3, n minus 3. And you'll have a negative 3 answer, and you'll have a positive 3 answer. So those are your three answers for number 4 with the 4 terms. Always trying to find out what's going to make the parenthesis equal 0 when you want to solve it. Number 5, a little different, so I did that right up here in the middle. You can see it. I got it equal to 0 first. I subtracted 21p so that it equals 0. And I look for my GCF, which is a 3, because you can divide them both by 3 and get a whole number, and you can take out a p. So 3p is my GCF. That means one answer is 0. And then I have a p squared left over, and I've got a 7 left over because the p's cancel out. 21 divided by 3 is 7. So I need to solve this equation. So I add 7 to both sides. I get p squared equals 7. Square root it, and you get plus or minus radical 7. So 0 is one answer, positive radical 7, and negative radical 7 are your other two answers. I'm not going to do 6 because it's very similar to 5, so you can do it the same way. But you don't have to do that one. Just do the ones that you see me do on the video notes. And then on practice B, you're going to do all of them except for like the last problem. So on practice B are the last 2 problems you can cross out, but the rest of them you need to do. All right, when we get to 7 through 10, it does say to find the zeros, meaning solve and then sketch a graph. Now you don't have to sketch the graph, you just have to get me a screenshot of the graph. So you're gonna type in the equation into Desmos. You can put a y equals there. And in this case, you'll see there's 3 places where it touches the x-axis. A -4, a 0, and a 3. Those are going to be our 3 solutions. So if we go back to number 7, which I did right here, I went ahead and I did my factoring. I took out an x squared because all of them had at least x squared. I took that out. I was left with x squared plus x minus 12. And I drew my x with my -12 on top and my +1 on the bottom. So I need a +4 and a -3 as my 2 factors. So x with a +4 and x with a -3. So now I got to find out what's going to make all these zeros. Well, one thing is that x could be 0 because that's outside. X is on the outside as a GCF. What would make this parenthesis 0 would be -4 plus 4. That'd be 0. So -4 is a solution. And 3 would make this one 0. So 3 would be my x there. So I've got 0, -4, and 3. And that's exactly what we saw here on the graph. 0, -4, and 3 were our 3 solutions. So you're going to do the same thing for 8. Solve it with the, well, you don't have to do it on this one, but on your other page, make sure that you screenshot your graphs for those 4. I'm only going to do 7. 9 is the same as 7. 8 is the same. No, I actually did 8. My bad. Sorry. 8's over here. I didn't bring a screenshot over, but you can do that on your own. So I just factored it. I just used the x. I put a 16 on top. I put the -8 at the bottom, which is -4 times a -4. So x squared minus 4, because you got to use x squared here, because you need x squared times x squared to give you this x to the 4th. Now that I know that it's x squared minus 4, these are a difference of squares. X plus 2, x minus 2, because you got x times x, you got 2 times 2. So you can put an x plus 2 and an x minus 2, because if you do FOIL here, you're going to get back to your x squared minus 4. So now you can see your 2 solutions, -2 and +2. Typing this into your Desmos would give you these 2 solutions. You'll see those 2 answers. You don't have to do that on the notes, but you will have to do it on practice B. 9 is the same as 7, so I'm going to go to 10. I did 10 over here. And if you notice, first thing I did was I took out a -3 because I need this biggest term to be positive. So I got to divide by everything by a negative to get that to become positive. And I can take an x out. So I'm going to take out a 3, a negative, and an x. So if I do that, I'm going to get -3 divided by -3 is 1. Had 3 x's, I took out 1, so I get just 1x squared. You can see that right there. When I divide the second one by -3, -15 divided by -3 is +5. Had 2 x's, I took out 1, so it's just going to be 5x right there. And then -12 divided by -3 is +4, and the x came out, +4. But remember, 3x is our outside. That's our GCF. And since x is part of that GCF, your one answer is 0. Now you can do your factoring. We need it to equal a positive 4 when you multiply. So 4 times 1 is positive 4. You need it to add up to 5 when you add. 4 plus 1 is 5. So negative 4 and negative 1 would be your two solutions there. So 0, negative 4, negative 1 for 10. Let's see, 11. It's called the rational root theorem. It's right over here. And it's talking about the factors of the constant being on top of the factors of the lead coefficient. So that would tell you what are possible roots. What could they possibly be? It would help you eliminate ones that can't work. So what are the factors of 6? That goes on top. 1 times 6 and 2 times 3. Those are all factors of 6, and they could all be plus or minuses. Factors of the first number, which in this case is a 1, would just be 1 and plus 1 and minus 1. So the factors of the last one go on top, the factors of the first one go on the bottom, and then you find all your possible answers down here. So that's what we did on number 11, is we took the factors of the last number, which is 4. So you have 1 times 4 or 2 times 2. The factors of the first one are 3, 1 times 3. So those are our two factors. So I'm going to take these 3 and I'm going to put it on top of the 1. So I take these 3 and I put it on top of the 1. And I'm also going to take these 3 and put it on top of the 3. So 4 over 1 is a possible factor. That eliminates the first one. 2 over 1, that's not any of my answers. 1 over 1, they're all possible factors. 4/3 is a possible factor. 2/3 is a possible factor, so I can get rid of the 2/3. 1/3 is a possible factor, so I can get rid of the 1/3. But negative 3 is not a possible factor. I do not have a 3 over 1 anywhere. So negative 3 is the one that's not a possible factor. Number 12, what was their mistake? They just did not get all the factors of 18. 2 times 9 is 18. 3 times 6 is 18, but they forgot 1 and 18. So they needed to put a plus or minus 1 and a plus or minus 18 for this back number. So that was their mistake. Moving on to the last two. We're not going to do 15 or 16. We can cross those out. So number 13, though, you can do. It's right down here. You can solve it. It's a really quick one. You've got, now look real quick at the directions. Find all real solutions. Real solutions. Hint, hint. There may be a few that aren't real. Here's our equation. Equals 0. No, there's a 1 in front, so I can use an x. That negative 9 goes on top. The negative 8 goes on the bottom. So negative 9 times 1 is going to be negative 9 when I multiply. Negative 1 and 8 together gives you negative 8. So that works. So my one factor is negative 9, but I have to use x squared because I need x to the 4th. X squared times x squared is what gives me x to the 4th. So it's got to be x squared plus 1 for this one, and x squared minus 9. X squared minus 9 is a difference of two perfect squares. X squared is x times x. 9 is 3 times 3. X plus 3, x minus 3. So negative 3, positive 3 would be your two answers there. X squared plus 1, you need to subtract 1 on both sides. But that gives you a negative 1. And you bring down the x squared. When you square root both sides, you're going to get imaginary numbers. So you're going to get a plus or minus I, because the square root of negative 1 is really I, imaginary. So plus or minus I. So that can't work. So your only answers are 3 and negative 3. Number 14 is not factorable. So you would plug it into Desmos. Just type it straight in. I did that for you right here. Okay, you can see the curve, and you can see the three solutions. Negative 3, negative 1, and 2. So great tool. Desmos is a great tool to find the solutions. Those are the real number solutions to our graph. So that was it. So make sure you put a screenshot of your graphs. You can do the screenshots of the two that I did there. Plus, when you get down here, you're going to sketch a graph. You're going to need the screenshot of these 4. And you can even screenshot both of these if you want to do that and show me the real solutions down there for those two. All right, so that is 4.5 practice A. Your job is to do practice B and puzzle after you've taken the notes.